Good morning, everyone. Welcome to the Agoric Asset Workshop. I'm Wietse Slagman. I'll be giving the introduction on why we're here, what we're doing, who we are as Kryha, and then I'll give the word to Carlos to give you the in-depth workshop, give you the assignments, and just take you to the code of Agoric. So, what's today's goal? So we want to arm you with intuition and know how to build NFT dApps on Agoric and create your very own first NFT contract. We of course have a reward of $200, as you probably already know. So that's going to be the goal. We'll have a few topics to discuss, which I'll go through now. So I'm going to give you a short introduction on who we are as a company, why we are here in front of you right now giving this workshop as Kryha. And then I'll give you an introduction into the project of the character builder. Dean already mentioned some of it yesterday in his talk on what we're doing, what we're building exactly, and I'm going to give you just a recap and just maybe some more in-depth information. And then we'll go into actual Agoric stuff, like some of the concepts and some of the actual development. How do you go through the flow? What does the app look like? What other core concepts are there, such as OCAPs and ERTP? We'll then take you through some coding examples that we've created for you to really give you some practical knowledge on actually developing this, because concepts are important, but what's more important is actually getting the code out there and just starting to write it. So who we are and as Kryha. So we are actually a blockchain studio who focus on Web3 ventures, and we also have an enterprise business. So what we do is basically build user-centric applications, blockchain applications. We are kind of stack agnostic, so we build currently on Agoric. We also build on Ethereum, EVM compatible chains. We've also done some substrates, so we're quite a big palette. So why are we here? So we're currently building a project for Agoric, or together with them, where we're actually creating a character builder app, which is based on NFTs. I'll get into detail about that a bit later. So we're here to share insights and tools needed to actually develop applications, give you some insights, some tips. What did we run into when starting projects? What did we run into when starting to build contracts? What are some weird things to think about? What happens, etc. So the character builder, what is it? It's a composable NFT in that sense. So you have a character on top, and that's an NFT in itself. And that character NFT can actually hold other NFTs, which are items. So you can actually equip and unequip items on your character. What that means is basically that you transfer ownership of that item from yourself to your character. That means you can't do anything with it anymore unless you unequip it and basically bring it back to your own wallet / purse. So what we're going to do with this is we're trying to launch this as one of the first apps on Agoric mainnet once that's ready, and hopefully get it also into your hands. What does an app look like? What does it feel like? How does it use on Agoric? And also give you some of the source code that we've used to build it, so you can also build your own composable NFT contracts, maybe less gaming focused, more in art space, whatever, because composable NFTs are quite powerful in what they can do. And yeah, this is basically what it looks like. You might have seen it. So you basically have your character here, and it has some stats to it. And then you also have the items, which also have stats to it. And basically that together gives also a score. So you kind of can compose your own character, what it looks like, what it feels like, how strong it is. And yeah, this is basically what it looks like and what we're still developing. So we're still under heavy development. It's not done yet. But hopefully somewhere in June as well, we will be done with this and have it ready for the mainnet launch. And that's it for me. And I'm going to give the word to Carlos to get some of the concept going and the real in-depth presentation stuff.
Cool. How's everybody doing? I'm just going to switch the mic real quick and then get started.
All right, cool. So before we start, I'd like to maybe get a feel for maybe how much Agoric you guys have been exposed to. and maybe depending on that, I can go more in depth or less on certain topics. So how many here have attended the workshop yesterday by Martin? Okay, looks like almost most of you. Cool. So I talked with him about how it went. I didn't attend myself, but from what he said, I think you guys went through a lot of the conceptual stuff around the concepts of Zoe and the contracts, and but mostly was through testing. Is that correct?
Yep. Yes.
Okay, cool. In that case, I think I will be focusing a bit more on the whole deployment aspect of it, and essentially the interaction between the UI, the wallet, and the contracts, as well as like different possibilities or ways that you can structure it. Because honestly, there are a lot of different ways that you can do this, and that's kind of, for us at least so far, it's been the most troublesome part. Like the contracts just work. Everything just works, but when it comes to deploying, there's a lot of stuff to do there, right? And this is also something that I believe the Agoric folks are currently working to improve, which shouldn't be too bad. Like I'm assuming you can write a lot of packages on top of that to make that easier. So that experience should improve soon, but for now, I want to get you a feel for it and maybe get you started on it. That being said, here's what I intend to talk about. So, like I mentioned, the Agoric side of things as a concept. So I think I'll just go through those fairly quick, since you guys have probably already heard about it. It's a little bit difficult to wrap your head around. Don't expect to understand all of these things in one day. It does take a little bit more, but yeah, hopefully just talking about it more can help. So once we've gone through the concepts, we'll go into practice. And I don't have a whole lot of slides here, but my approach is going to be to just go through some code, go through some examples, and then we've put together a repo where you guys can go ahead and download, and we can do a bit of coding. I've just removed parts of the contract, and then we'll just fill it in together, and hopefully you'll be able to mint your own NFT. So with that said, let's go ahead and get started. So what is it, right? What is Agoric? It's probably not my place to explain all of this in detail, so I'll just run through it fairly quick. But you can actually chase it down all the way to papers published in '88. So it's not quite the new idea, but they've been putting a lot of work, and they've been shaping JavaScript to be able to support this kind of programming. But essentially, I'm not sure if you guys are familiar with the stack overall, but you essentially have different machines that are connected through these VAT protocols. On top of that, you have the JSON object capabilities, and then one more layer of abstraction, you have the e-rights, and that's where the smart contracts live. When you put all of this together, you get Agoric, and like I said, I'm not the best one to explain this, but they have a YouTube channel with a bunch of videos that go into detail about all of these things. So I'd recommend, if you're interested, go check that out, or even read some of the papers. They can be pretty interesting. Okay, so why should you use it, right? Why should you choose to go and build on Agoric? So there are three main things I think that are promised here. So it's composable. So you can easily build, publish, and use different components and modules. What this means is that you can create a contract for, to complete a certain function that you can later publish, and anybody with the reference to that can just import it in their application and use it. Then we have the JavaScript first, and this is, well, it's not quite JavaScript. It's secure ECMAScript, which we'll get into in a minute. But yeah, that's of course a nice thing. A lot of people know JavaScript. We're familiar with it. And it's also nice that you can use it all across the stack. So you write deployment in JavaScript, you write the contract in JavaScript, and you write the front end in JavaScript. I suppose you could use maybe something else for the, well, no, you still have to interact with JavaScript. And then it's secure. So as a project, I believe Agoric has put a lot of emphasis in security. I think it was one of the main forces driving it. Is essentially the concepts of offer safety or the principle of least authority. They've put a lot of work into making JavaScript secure, and a lot of these things I don't really understand, like deep down in the protocol layers, but yeah, given some of the documentation that I read, I believe that they have a big emphasis on security. So yeah, those are the three main things. With that being said, so let's get into secure ECMAScript. Maybe some of you have seen this before, but this is essentially, so you have ECMAScript all the way at the outer layer, which is your normal JavaScript. And here you have all of the things that they've sort of removed or, let's say, adjusted in order to make it secure. But the gist of it, and I guess one of the main concepts that they've achieved with secure ECMAScript is that they sort of compartmentalize the different packages that are, or well, not just packages, but anything that you want. You can run it separately and only give it access to what it needs to have access to. So one of the main issues nowadays is that in a normal JavaScript application, you end up using a lot of packages, right, from other people, and I think on average like 90% of the code or 99% of the code of most applications is not written by you, right, or by the developer behind it. It's just a bunch of other packages that are imported, and currently these packages would have full access to your application. So if a package contains malicious code, then it could also ruin your application essentially. Yeah, I had this for some practical stuff. Endo is a package that you'll have to use in the front end in order to enable the front end to use secure ECMAScript. And there are a couple of different ways to do it. I find it's a little bit finicky at the moment, depending on your front end solution. You might run into some issues with secure ECMAScript. But with a bit of troubleshooting, if you just chase down what packages you're importing and what kind of things you're using in your front end, you can essentially make it work. But yeah, hopefully there will be a more robust way of doing this in the future. But yeah, we'll get into it more in the coding things. So then we have the concept of object capabilities. Is this something you guys talked about yesterday?
No.
No? Okay. So, all right. So object capabilities is essentially the idea that if we have the three actors here, right? Alice, Carol, and Bob. Bob doesn't have any reference to Carol. However, Alice, by invoking, I might have to read this because it's still a bit confusing in my head as well. But if Alice has a reference to Bob and invokes Bob passing Carol, then Alice has essentially both used her permission to invoke Bob and given Bob permission to invoke Carol. So essentially it's like Alice goes to Bob, like sends a reference to Carol with foo, and then Bob can essentially, so this could be like a greet function, right? Say hello. And then essentially Alice can enable Bob to say hello to Carol without Bob having any reference to Carol at all. And it's the idea of object capabilities that is the object itself that contains the rights to perform a function rather than the current paradigm of identity within other systems. I recommend watching the certain talks. Mark Miller has some really good ones explaining this concept, and it's on the Agoric YouTube. So I'd recommend checking that out. Cool. So the ERTP is the Electronic Write Transfer Protocol. This is essentially the layer that that takes care of all the assets within Agoric. And there's a lot to unpack here, but like I said, it's not really the main focus of today, but really quick, I'll just get you introduced to some of the concepts. So we have a digital asset will be represented as a brand. So essentially when you create an asset, be it fungible or non-fungible, it will have a brand that will, it's essentially like a name, like a way that you can refer to that one, to that asset. Now, there's a human readable name that you can give it, but in the code, it also gives you a reference that's unique, because the names would not be unique. But essentially, when you create a digital asset, it'll give you three things. It'll give you an issuer that essentially validates and stores the balances. It will return a mint that will allow you to control the supply of that asset. So it'll allow you to mint new assets of that type. And then it will also give you a brand, which is essentially used to identify that asset within the network. So if I create an asset and I now try to send you well, some of this asset, then you could go and verify against the brand to make sure that that is the asset that I am indeed saying I'm giving to you. Yeah, and then assets can be fungible and non-fungible and semi-fungible. So this is a new thing they added recently where essentially you can have a non-fungible token with a supply, which means that all the properties of the NFT are the same, only there is more than one. Cool. So again, this might make a little bit more sense once we get into coding. Let me also keep track of the time because, okay. Oh yeah, so wallets, purses, and payments. There's one more thing here that I want to talk about, which is amounts. And so from the top, we have the wallet, which is essentially when you're running an Agoric project, your wallet is locally on your machine. So you run what's called an ag solo, which is a chain that runs in your computer and gives you access to a wallet. Now, the wallet, use the wallet to interact with DApps, which essentially when you run a front end that integrates with an Agoric app, what you need to do is you need to suggest to the wallet to install the application or the contract that's deployed on Zoe. So in the front end, you would have some code that would say, it's going to look for wallets on your local network. It will find your wallet, and then it'll tell your wallet, hey, my application uses this contract. You should install it. And then from the wallet, you'll have to go in and say, okay, I accept, and that will grant access to the UI to some of the methods of the wallet so that you can interact with the contract. So that's one of the purposes of it, but of course it also holds purses. Purses are essentially a so it's basically like a wallet that holds a type of asset. So it can only hold one type of asset. However, you can have as many purses as you'd like. So, for example, Inter, you could have your main purse with Inter, but you could create a separate one that you can then use for a specific app or something like that. But essentially what you need to know about purses is that it holds assets and it can only hold one kind of asset at a time.
If these purses are specific to whole Cosmos, or is just Agoric?
I believe it's just Agoric. Yeah. Yeah, in fact, I mean, these assets as well, I believe they are also specific to the Agoric platform. And Yeah, one thing also to note about purses, you can also use purses in the smart contracts. So you can create a new purse. However, there is a distinction because the purse that lives in your wallet is long term, so that purse will always be there whenever you run your wallet. However, in the contract, if a contract on Zoe has a purse with a payment, and now something goes wrong with that contract, it crashes or something like this, then there wouldn't be a good way to recover that. So you have to be a bit careful about using purses in smart contracts as just a container to hold things. Cool. And then we have payments. And payments are essentially, it's in code. It's a type of variable that can hold assets as well. And it's kind of what you would use to transfer things or transfer assets from one purse to another. So for example, when you mint an asset, what that will return is a payment that you can then go and deposit into a purse. And then the last thing that I wanted to talk about was amounts. So all of these things actually hold assets. Like the assets are within it, are within the payment, within the purse and the wallet. Like these hold value. Amounts, however, refer to assets, but they don't hold any value. So amount is another variable type that you can use to essentially refer to an amount of a brand of an asset. So if I create a new token and I call it Kryha, then I could create a new amount which contains two things. One is the brand, and the second one is the value. So the brand just indicates what kind of asset it is. So this is where I would send over the brand, right? Like that just says what kind of asset I'm talking about, and then the value would just be a number. Now, one little thing here is that amounts work both for fungible and non-fungible tokens. So in the case of a fungible token, the value would be a number. In the case of a non-fungible token, the value should be either a string or an object. And these are the ways that you create an NFT. When you create an NFT, you pass in either a string or a list of strings for multiple, or an object. And so if you're defining an amount of an NFT, then your brand should be the NFT brand, and then the value should be the value of that specific NFT. Cool. By the way, if you have any questions, please just shout out. All right, so let's talk about the general approach to building a full application in Agoric. So first of all, we just write our contracts, which should be the main logic of the application, right? But it doesn't stop there, because then you need to write a couple of scripts to get the application into Zoe. So you first write a deploy script for the contract. I'm actually just realizing now, but there should be a line also going through deploy here. Because there is a deployment script for the contract that just says, hey, here's the code for my contract, bundle it, and put it in Zoe. What that does is it actually writes a reference to where that contract is installed in Zoe, and it exports it to somewhere in your application. Like normally, in a lot of the examples, they put it already in the UI folder, but it doesn't really matter. It's just a reference that you will need to use later on. And in fact, you will use it in the API script. So after having the contract deployed, then you go and deploy the API. This is a chance to do any sort of initialization of the contract. So for example, if you write a contract to create NFTs and you want to already call a certain method on that contract, then first deploy the contract, get a reference to it, run the API deployment, and in the API deployment, you can actually already use that reference and call methods on that contract to have some sort of initial value. This also enables another thing which they call spawners, and what that is, because so far these two scripts that I talked about, you just run once. It's JavaScript, just runs in Node, deploys it, and that's it. But in some cases, you might want to have a server-like thing running persistently. And they have these things called spawners that you can also deploy to Zoe that would essentially act as such a thing, where you can actually define endpoints that you can then use to interact with your dApp. So for example, let's see. So most of the contracts, are you guys familiar with the idea of like the public facet versus the creator facet? Okay, just real quick for those who don't know, when you write a contract, you end up with a public facet. That essentially anybody with a reference to that contract can make calls to this public facet and then run any methods that are within it. So here's, for example, where you could have a function that returns a list of the NFTs available in a contract or something like that. And then contracts also return a creator facet. And this one is meant only for the person that deployed that contract. So for example, if you have an NFT contract that has a mint function, then you probably don't want to open up that mint to anybody for them to create supply of that asset, right? So yeah, now this creator facet would only be available in the in the API script, right? Because that's where you create the instance of the contract and it returns the creator facet. And then, but because if the API script is only run once, then you're kind of stuck because you're not really, the creator facet is not just a reference that you can store in a file or anything like that, right? So that's where the spawners come into play, because you could deploy a spawner that takes the creator facet, and then, yeah, I mean, you may or may not want to do that, but like that's just one option, right? That you can create an endpoint that runs persistently on Zoe that grants users on the UI access to that creator facet. So that's one of the things that you could do. Okay, yeah. So once you've deployed your contract and your API, that all goes to Zoe, and yeah, and then you need to write your front end, right? Your UI, and in your UI, you use the references that are exported from the deployment scripts, the reference to the Zoe board where the contract lives, and that's what allows the UI to call methods on it. And then this is essentially the interaction between it. So you have the user, which is represented by a wallet in the local machine. And then that wallet interacts with the UI through what's called a local bridge. And then the UI, so the UI interacts with the wallet, and it allows it to call methods from Zoe. So with this, when you give permission to the wallet to use that application in the front end, the wallet is essentially sending over a reference of itself, so that it can the front end can call methods on its behalf. Well, call methods on its behalf, it sounds a bit insecure, but it all goes through offers that need to be accepted in the wallet anyway. So it's not like you can just arbitrarily call methods that without the wallet. Let me see how we're doing on time. Okay. All right, so let's talk a bit about the dApp structure. This is kind of what you get when you start a new Agoric project. So the file structure looks a bit like this. You have the API. In the API, you will have your deploy script. This is what's using the reference from the deployed contract, and it's your chance to initialize a contract or pass in certain init functions and things like that. Now this handler is what would have the persistent running code that I was talking about earlier. And then, so that takes care of all the deployment stuff for the API. Then you have the contract folder, which will contain the contract itself. And it should also contain, I didn't put it here, but it should also contain a deploy script in here, just to deploy the contract. And most of the time, the deploy script on the contract itself, it's pretty basic. Like most of the times, you won't even have to touch that. But you may want to just rename some variables and things like that, if just to have it go according to your application. So then you have the tests, which is a good way. I believe you guys used the test in the other workshop just to go through things, and it's very powerful. Like it's really good for for messing with the contracts and interacting with it, trying out different functions. It's a quick way to do it because you can just rerun it without much hustle. That being said, whatever happens in the contracts may not be, in the tests, may not work exactly the same way in the full application. And what I mean by that is not that it's random behavior or anything like that, but there is a lot of components that you need to adjust to perform the actions that you can do very easily in the tests. So hopefully today I will give you a bit of a good overview of what those are and where you need to go to adjust those. So finally, you have the UI, which the UI actually you can do any sort of UI in there as long as you're able to use secure JavaScript to make some of the calls to the API. Then you should be okay. You can have a React app. You can have just a plain HTML CSS app. You could have, we're currently using TypeScript with React, and that after some troubleshooting, like I said, with secure ECMAScript, we managed to get it to work. So this is the basic structure, and you may notice here this conf folder, and that's where the constants are, which is basically what's being exported from the deployment of both the API and the contract. So we'll see that in code in a minute. But let's see. So this is a bit of the flow. So you have your contract. You deploy the contract that exports the constants to that dApp constants over there. In this case, is within the UI, but you could have it in a different directory if that was more convenient for you. As long as the API deployment has access to it and the front end has access to it. Because you will need a reference to those contract instances there for the deployment and for the UI to work. Cool. So from here, I wanted to maybe walk through some actual code examples that are on the Agoric website, because I think just talking about it it's a little bit hard to grasp, but it might make more sense if we just go through it a bit. Yeah, sure. If you're developing an application on Agoric, they do have a lot of resources that are very useful. So from their main website, you can just go to the documentation, and where you will find code example is actually on their GitHub. You can get to that through Zoe here. If you go to GitHub. Now, if you just go to the Agoric repo here on GitHub, you'll find, so there's a few things. If you're only interested in contracts and how contracts can be put together, you can go to the SDK, and in packages, Zoe, and source and contracts. Now here you'll find a few examples of different things that you can do. These are also documented in the docs here, I believe, right under here. So they talk about a bit about what they do, and then, but yeah, essentially this is the contract file alone, right? So this is more for if you're wondering how certain things are done within the contract, then you'll want to go here. For our case, because we want to know how the whole app is put together, we need a more complete example. And they have those just under the Agoric repo in here. So you have the Treasury tab. You also have the DApp fungible facet, which is the one that we're going to go through in a moment. And there's a few more, so the simple exchanges and the card store. But I want to showcase the fungible facet here, because I believe this one uses a spawner. Yes, okay. Cool. So, all right, like I said, the folder structure is like we said, right? We have the API, the contract, and the UI. So let's just start over by seeing what the contract does. And then we'll chase it from there. So if we look at the contract, one good way to realize what the contract is doing is, of course, to look at the tests. And then we can see here that it's testing the mint of a payment. So what this is doing, this is actually also taking care of installing that contract. And so first it creates a fee purse that's going to essentially pay the fees for the interactions with Zoe and the chain. And then it bundles the source, so it bundles the contract. That gives a bundle that you can then install into Zoe. That gives you an installation, which an installation is just a reference to that contract code on Zoe that allows you to essentially start an instance of that contract. So to do that, you just do start instance and you pass in the installation, and that'll give you the creator facet. And also, I mean, depending on what the contract does, if it has a public facet here, it would also return that, as well as the instance. So, as we can see here, it's commented that Alice makes an invitation for Bob that will give him 1,000 tokens. So it's using the creator facet to make an invitation, and it's creating a seat from that invitation by saying by making an offer to Zoe. So then that this make invitation is essentially a method that's written in the contract. So let's go ahead and just have a quick look at that so that we know exactly what's happening there. So if we go to the source, we'll find the contract, and Agoric has gone ahead and in all of these examples, they've provided a lot of documentation within it, which is quite nice if you're trying to understand what's going on. So if you're writing a new contract, I'd suggest just grabbing one of these contracts and just starting from there, just so you get a feel for what things are doing by reading these docs. Now, usually the best way to start reading a contract or to go through it is to go all the way down here to where you return. So the return of the main contract. Now, one thing to note as well is all of the contracts in Zoe only consist of one function called start. And then the best way to start looking at the logic of a contract is just to go to the return of that main function. And as we can see here, it returns a creator facet and a public facet. So if we go to the creator facet, we see here what it's doing. So it's essentially returning two methods. One is this make invitation, and the second is a get token issuer. So here, this make invitation is taking the function mint payment, and is essentially making that available to anyone that received that invitation. So in the test, we saw that Alice was creating an instance, and she was getting the creator facet, and then from there, she was calling the method make invitation on the creator facet. Now, that's kind of the flow of how you would interact with the contract, and that can often happen in the deploy script for the API, but we can also call these methods from the front end when having a reference to it. Now, if we look at the mint function, what this is doing is the function that's actually creating minting the assets. So, like the name indicates, this is just a fungible facet that allows to mint a fungible token to whoever uses it or receive an invitation to it. So the way that it works here is, first of all, we defined the asset. So there's a couple of ways that you can do this. Here is using ZCF, which is the Zoe. Okay, I forgot that name, but contract facet, right? Okay, the Zoe contract facet. Thank you. And is calling make ZCF mint. There are basically two ways that you can create a token or an asset in a contract. One is through a function called make issuer kit. Now, make issuer kit, I'm just going to write here, just deconstruct what's going to return. And then, because I'm writing really big, I'll just put the arguments down here. So for make issuer kit, takes two parameters. First of all, it just takes the name of your token in the form of a string. So essentially, what you want to name your token. Now we can imagine if I wanted to make a token, I don't know, Kryha. I would write it like this. And then secondly, you need to pass in what kind of asset you want it to be. And this is where you have to choose between a fungible token and a non-fungible. For a fungible token, you would use asset type so for an NFT, it's type set, and then for a fungible token is type yeah, this is using a different one, but nat. Now, like I said before, so all assets, regardless of whether they are fungible assets or non-fungible, they're treated the same way by things like amounts or payments or offers. It essentially doesn't really matter. Like it can also perform the same operations whether the asset kind is set or not. And then this will return three things. So it will return the issuer. It will return the mint. And it will return a brand. So once you make an asset, you can use these things to perform different things within Zoe. So like we talked about, the brand is essentially what identifies that specific token, and the mint is what allows you to essentially create more supply. So this will be a method that you can call in order to make more of that kind. And then the issuer is something that you can pass also to identify that is the, it essentially keeps track of the supply internally, and it's something that you can pass along for Zoe to be able to check that specific token and who owns what and all of that thing. So this is one way, and then the other way is how it's done here, which is through the make ZCF mint. The main difference between these two is if I this one has a function called mint gains that will essentially synchronously allocate the funds directly to the seed. So the seed is essentially it essentially identifies who called that method. So, for example, if Alice calls or gets an invitation to call mint payment here, then she will receive a seed that will represent her in this contract. And the advantage here with mint gains is that this, rather than returning a payment object that you can then utilize within your contract, this will automatically send the funds to her wallet once the seed exits. So the nice thing about this contract is very simple, because you just, first of all, you make the amount here, which is how much you want to mint. Like we talked earlier, this doesn't really hold any value at this point. Like just defining that you want to make an amount of 1,000 of this brand, the brand is there, that holds no value at all. It just indicates, it represents, it's a way for you to describe that you want 1,000 of that. And that's then what you pass on to the mint gains to indicate how much you want to mint. So here, this is where the minting actually happens. The tokens are created, and then you pass on the seed so that when that exits, the payment should be received from Zoe. This is a little bit different because, so as you can see here, when you make the token using this method, it will return the mint directly. But from the mint, you can actually call get issuer record, which will also give you the issuer and the brand. Now, these are important because you want people outside of this contract to be able to verify and know what kind of asset this contract holds. And that's why you will see this a lot in a lot of the contracts. You'll have a function get token issuer that will be available normally in the public facet, so that anybody that wants to interact with this contract can actually get the issuer. This is also important because remember how we said that purses can only hold one kind of asset? So if we wanted to create an application that mints tokens or assets, then we need to have a purse in our wallet that is able to receive that kind of asset. So if we weren't able to get the brand or the issuer here, then we wouldn't be able to create a purse in our wallet and then we wouldn't be able to receive payments of that brand. Cool. So yeah, let's keep going here. Because so far we've only looked at the... How are we doing, by the way? Do you guys need a break? No? Okay, cool. Love it.
Maybe just a quick question.
Sure.
What's the difference between issuer and brand?
Right. Okay, so let me go back to this. So I don't know like the inner workings that well of how this all operates. But the brand itself, it's just something that you use to refer to that brand, as in when you create an amount object, you pass along the brand. But the issuer has a little bit more than that. So it actually validates and stores the balance record. So with a brand alone, you wouldn't necessarily be able to know how many of those assets or check balances and things like that. For that, you actually need the issuer.
So that's in that contract when there is that get method, so that it returns issuer for that reason.
Exactly. Yeah, because then so a brand alone would not allow you to create a purse, for example. I think. But anyhow, what you can get out of this is that brand is mostly to indicate the kind of asset, whereas issuer is a little bit more involved. It actually is a little bit more useful, and it's used more in the interaction between the UI, the wallet, and the contract. So most of the time, you'll be passing the issuer from the contract to your UI or to your wallet or to other contracts for them to be able to know about this whole token, right? So yeah, sorry, yeah, I think, I don't know if Dean has any more office hours.
I think so at the end of the day. But yeah, it's important to note that if you only have the brand, you are never sure that you're getting the token that you want. The brand and issue together, those basically make sure that you get the exact token that you want, because then you know, okay, which contract you're exactly interacting with and which issuer actually minted that asset. So you can kind of make sure that together with those you get exactly what you want. With the brand only, it's often alleged or inferred that, okay, it's probably this issuer, but you can't really trust it in that sense. You need both to make sure that, okay, this is fine, this is the asset I want, or this is the asset I want to give.
Right. Cool. So let's get back to this. So okay, now we have a pretty good idea of what the contract does, right? We have the creator facet that is able to, that returns a make invitation method, which calls the mint method, that takes the seed, mints the NFT or the fungible tokens, and then it allocates those directly to the seed by using the mint gain function. So now that we understand how the contract itself works, let's go ahead and look at the deployment for it. So in the contract folder, we will have a deploy.js, which is going to do something similar to what happens in the test, where you bundle it and you install it in Zoe. So this will have a function here, install bundle, that will take the contract by using this path resolve, and it will just use the method bundle source, which comes from here, endo, which is that secure ECMAScript package, and that returns the bundle, and then you actually call install on Zoe by passing the bundle to it. That gives you an installation. And then, so that installation is what you need to make available to the API deploy script in order to start an instance. The way that we do that is by first calling getID from the board. The board, you can think of the board as a bulletin list of like what kind of what contracts are installed in Zoe, in that particular instance of Zoe. So it just has a reference to it, which is a board ID that will point to that installation. So once you get your installation board ID, we just log it so we can see that. It can be very useful for troubleshooting. And then we have the deploy contract here. So here, what it's actually doing is installing the okay. So this is called first, and that's what calls the install bundle function that we just talked about, right? So the deploy contract first just gets the references to Zoe and board from home, which are then needed, of course, to install the bundle into Zoe and then get the ID from the board. So most deployment scripts will look like this, where essentially you're just getting Zoe and the board from home, which is your ag solo, and then you're essentially getting the installation board ID, which is a reference to the bundle that you installed in Zoe. So what's happening down here is essentially we're forming the constants that we're going to use. So we pass in the contract name as well as the installation board ID. And then we just use the file system package to write that to a file that we can then access in both the API deploy script as well as our front end. Is that clear? Is there any questions around deployment of the contract here?
Just ask to the creative asset, so it's something that you'll run only once with the API deployment script, and then those methods are never used again.
No. So those methods are available. So you have your smart contract that you deploy onto Zoe, and then that contract will just be running in Zoe. So if you have a reference to that contract, then you can get access to the public facet of that contract. Were you talking specifically about the creator one? Yeah. Okay. Sorry. Yeah. In that case.
Confused about the difference a little bit. So.
Right. Yeah. It'll become more clear in the next file that we're going to go over here now, which is the deployment one. So the API deployment. So let's go ahead and look at that. Because so far all we've done is we bundled our contract and we put it in Zoe, but that's about it. It hasn't been initialized. No actions were called on it. It's just installed and we have a reference to it. So
I'm quite confused. You are saying you are deploying that to Zoe, so not to the blockchain. That's confusing for me.
Yeah. So within Agoric, a lot of the blockchain things are abstracted away. So for example, you won't be looking for transaction hashes, and you won't necessarily be interacting with block numbers and things like this. But there is a chain running, and exactly how the interaction between the chain and the what's called the electronic rights protocol, it's a little bit beyond my understanding at the moment. So there is a lot of documentation out there for it. So I'd recommend just going to the Agoric docs or just checking out some of the YouTube videos and talks that explain that in more detail. But the scope of this workshop is more on the practical aspect of it. So we actually won't really be talking about much blockchain-specific things, even though this, of course, does run in a chain.
What might be important to note is that you basically have the blockchain underlaying underlayer, which is mostly Tendermint. That actually Agoric is more of the JavaScript VM that runs on top of that. So that's what you're interacting with through Zoe. So by installing True Zoe, you install it basically on the JavaScript VM, which handles all the blockchain's transactions for you, does the transactions, looks at the blocks, etc.
And that VM is running on my machine or on the validator server?
So currently for us it's running on your machine, but there they have a Zoe instance that's running on the validator machines.
Okay.
Correct. Cool. So then let us look at the deployment script here. So for deployment, this one just exports the deploy API here, which first of all also gets access to home, which gives it Zoe, and then so here's where, whereas the contract deployment script is usually something that you won't have to mess with a lot, this one you should be paying attention to, because it has different functions that you may or may not want to implement. For example, the spawner here, which is that persistent backend-like mechanism that you can deploy on Zoe and have endpoints run logic for you with access to anything that you get access to here, which includes the creator facet. So, for example, if I didn't want to have that persistent API running, I wouldn't need to get the spawner nor HTTP or Scratch. I would only need the board and Zoe. But let's just see how this does it. So first of all, it takes the installation constants, which is the file that was just written now by the contract deployment script. So now we have a reference to the installation board ID. And then first of all, we're going to get the installation by calling getValue on the board and passing the installation board ID. And then we are actually going to start an instance of that contract. So here's where you could pass, for example, a contract may have certain values that you want to initialize when you create an instance. So this would be a good place to do it. Now, when you start an instance, it's essentially going to return both the creator facet and the public facet, as well as a reference to the instance. And then, so, okay, that was successful, and we have a contract instance running on Zoe. So then, first of all, we're going to get the invitation issuer, which is a way for Zoe to be able to handle the invitations from a contract to a specific wallet. So that you can send an invitation to another user. Essentially, like in the tests, Alice is sending an invitation to Bob to mint tokens. So you may be thinking like, okay, but that's an issuer, and indeed, invitations are handled in the same way as assets. So you also get an issuer, and you also get a particular one for Zoe here. And then we get the brand. Now we have those. And here's what we were talking about earlier that was in the contract. Let me just pull up a reference to that here, where the contract itself was returning the issuer, which is right here, also in the creator facet. So that's the first method that it's calling here. So that gives you the token issuer, which is then something that you can use to, for example, create a purse in your wallet that handles that specific type of asset. and here it's it's setting up in the Scratch, which is also a return from home, and that's what makes it available to other cards by these faucet token issuer. Then we also get the brand, and we await the invitation issuer promise. So we can see here that it's using E, which stands for eventual send, which essentially returns a promise. And then down here, we're actually awaiting that. So then we want to get a reference to all of these things so that we can use them in our front-end application. So what we do is, similarly to the deploy script, we're going to ask the board to give us the ID for the instance, the token brand, as well as the token issuer. So here's where the spawner would, or how you would define the spawner. So you create this install URL handler, and then here is going to the handler. I'm not going to go into detail in the mechanisms of like how the handler is put together, because I can see that we're a little bit short on time. But I will show you real quick what that looks like. But that's essentially, it would act kind of like a server, like let's say like an Express server, right? Where you create endpoints and you handle logic for certain endpoints. So if we go to the API, and in the source you have the handler that you're seeing, it's being imported here. Right. So it's getting it's creating a bundle for that handler, and that handler is actually taking the creator facet, in this case, the board, the HTTP, and the invitation issuer, and it's creating this HTTP service where somebody can actually hit the endpoint, fungible faucet, send invitation. And then here to answer your question about the creator facet, so this would be running constantly on Zoe, but as we just saw, when we create this spawner, we're actually passing in the creator facet. So now you have essentially a sort of persistent application running here, where people can hit these endpoints. And these endpoints actually have access to the creator facet. So that's one way that you can actually, rather than just having the API deploy script run once, you can make it available persistently through this. Whoop. I want to make sure we have enough time to complete the assignment, but
take the app we created and to use that for the UI part.
Hmm?
The app we created,
right.
and we use that for the UI part, because the UI part is complete.
Yeah, for the example that we're going to do? Okay. So far we've explained in this example like how we've explained the contract code, we've explained the deployment of the contract, and we've explained the, actually I didn't finish explaining the API. We're almost there though. So.
Well, I got a question about this concept of API.
Yeah.
So can I imagine it like this is the way how can I interact with the creator faucet and allow people in calling something from my job and then make some logic in this API where I can really touch the creator faucet, which is not public.
Exactly.
But, okay. So here I can customize I can do some checks, I can mint something and do the logic here. And this API is also deployed to the zone. So it's not not my RPC. No.
Correct. Yeah, yeah. You don't have to. You don't need to push it to a server or anything like that. It's being sent to Zoe and it's being ran in Zoe persistently, and it has a reference to that. It has a reference to anything you pass to it essentially. So you can see here that that this just takes some arguments, right? And you can write anything in here as long as you then pass it from the deploy script. Then yeah, it gives you, essentially it just gives you that persistent running script with access to anything that you have access to in the run once deployment API script.
It's something new for me if I compare it to development on Solidity. There is nothing like that.
No, true. That's very true. Yeah. Yeah, it's very flexible. And honestly, after developing on this for a while, you find all these ways that you can actually architect applications, which can be a little bit daunting at first because you're like, okay, so many options, like which one should I go for, right? But I think it's also a good experience because it becomes really flexible in terms of what you can do. But yeah, we were almost done here with the deploy script. So once you've created that spawner, as you can see, so you're asking about like where that spawner lives. It's actually essentially bundled in the same way as the contract was. So am I in the right one? Oh yeah, down here. So it's using the same bundle source function, only it does have these special spawner thing here for installing it. But it does live on Zoe, and it's just there persistently. Now, the rest of this script here, it's once again just getting all of the references to the things that were just installed, and writing them to a file that we can later use in our front end. Okay, so we've covered a lot of the integration part, but so far we haven't talked about the front end yet. Given the time, I want us to maybe get started on the project that we're on the workshop example that we're going to do. So let's just, if everybody could clone this repo.
Typing QuickTime here.
Huh?
Try typing QuickTime here.
Oh yeah. Oh. He wanted to open QuickTime and so. But yeah, let me just talk a little bit about what we're going to do while you guys clone that. So, maybe I miscalculated a little bit on time. I really wanted us to do something that showcase a lot of different things. So I went for an example that's very similar to the baseball card dApp that's on the Agoric. I don't know if you guys have gone through some of the example applications, but what's cool about that is that it actually has two contracts, and you have the one contract that actually takes an instance of the other one, and I wanted to showcase that a little bit, and I also wanted to give you something similar to something that they have out there, because then you can also compare and see where things are changing and like the changes that you have to make and how those affect. And it just gives you a similar example in a different way that I thought could be useful. But we're going to provide essentially an almost working project, but we're going to go in the contract, and essentially I've just removed some of the stuff, and then we'll try to fill it in together, and then I'll walk you through essentially how it interacts in the front end, because I really wanted to get to that, but not yet. Yeah.
So each contract has its own WebSocket? Possibly?
That's a networking question I don't know the answer to. But how do you mean, or do you mean in the...
You made the spawner, right? And it spawned
Right.
a WebSocket connection. That's what you use to like connect to the REPL and stuff.
Yeah?
And so that's what you talk to in your front end when you want to interact with your contract. But wouldn't that, and which are the WebSockets run on like every single node around the world, or and like are you connected to a random one, or like how does that connection work? Because you make.
So one thing to note is that we're running this locally at the moment. So when you run Zoe locally on your machine, then it's only available to that machine.
Yeah.
There is of course the global Zoe that people can deploy to. At this moment, the testnet, but yeah, that's definitely out of scope for what we're going to be doing now. In fact, I myself haven't gotten a lot of experience in deploying to that. But from a practical point of view, what you need to know is from the front end, then you can actually just call the endpoint for the spawner, which is stored in the constants here. So you have it.
But that connection, as far as I know, I think handled through the wallet. So wallet does a lot of the connection directly to Zoe, which subscribes to a lot of those events for you. That's why UI always goes through your wallet as well to actually make a lot of those calls. So I'm not 100% sure if it's also for these spawners, but I think a lot of those WebSocket communications handled through your wallet, through the connection for that.
Cool. Thank you.
Yeah, well, yeah. So when you have the UI, right? You have the front end, and then there's a bridge from the front end to the wallet that essentially exposes the wallet to the front end. So the front end can get a reference of the wallet that it can then use to make offers. Those offers go back to the wallet for approval. And then it interacts with the contract, if that makes sense.
I have one question. So, as I understand, we can run almost anything like on pure Node.js JavaScript, and it will looks like Node.js API stuff, but it's on Zoe blockchain.
Yeah.
Somewhere like in the cloud. So I have a question. Do we have some like power limits or something? Maybe like if I want to, I don't know, put in this Node.js script some heavy stuff, maybe like game or Bitcoin miner, I don't know. So it will work on Zoe blockchain on this power like of those computers.
That's an interesting question.
Like free power for calculating stuff.
I think a lot of that's also handled by actual the SES stuff, where a lot of those things just do not run within SES because there's a lot of
some limits,
limits on that. But in terms of actual CPU limiting, I'm not really sure. Do you have any insight in that, G? Yeah, that's maybe a good question to ask Dean at his office hours, because I also I'm not really sure how they handle those kind of things, limiting CPU power or limiting the execution time of a script. But as far as I can tell or know, it's quite limitless in what you can actually do, and a lot of the execution is
Yeah, that being said, I mean, I don't think, like conceptually, you probably wouldn't want to rely too much on the API. Like the API shouldn't be thought of as a core part of the application, right? It should be thought of as a helper to interact with the contract itself. So I wouldn't recommend going and like adding a lot of logic that's essentially crucial to the application, because it doesn't really offer you what the contract does in terms of security and in general usability.
And is there already some kind of gas fee computing already involved in the testnet? So is this thing, is the computational heavy API, let's say, handlers, will they cost more gas? Or is the concept not at all in the average
No, there is gas. Yeah. Even when you run it locally, are you asking around how does gas
It
fees?
was probably a follow-up question on the how if
Oh.
there is any limit on this
Oh, on the API
and
one.
So if it is so that if I do it computational heaven, it will be basically more expensive.
Right. That's an interesting question, and I think we can probably figure that out by looking at this. And so essentially at this.
But maybe it's good to first get to the assignment and
Yeah.
get the question at the end so we can
Sorry.
Is that
we
okay?
really
Because
want to.
I think it's not super
Let's
relevant
build the
for
NFTs, yes. And
Yeah, then we can definitely answer the question after the talk.
Did we mention there's a reward, right?
Yeah.
Okay. All right. How's everybody doing? Do we all have the repo?
Yes.
Great.
Okay. Cool. So let's get this going. I should have it also here. So if all went well, you guys should be looking at something like this. Is that correct? Is this the file structure that we all have? All right, sweet. So now that we're experts on Agoric development, we can see that we have our UI here, which will be the whole front end for the application. And we also have our contracts and our API. So everything is kind of set up. The only things that I've done is removed some of the things from the contract itself. Now, that being said, there are two contracts at play in this one. So we have the NFT contract, and then we have the auction items contract. The auction items is taken directly from the baseball card app store, and it's a contract that will allow you to create an auction for an NFT. And we can see here that it has a so like we did earlier, it's good to always start from the return here, and then we can see what the creator invitation does. So this should have a function here to create or to sell an item. Oh, here it goes. So start. Okay, sorry, here. So here's where you sell the the item. So in here. Sorry, just 1 second. I'm trying to decide whether it's better to start with this one or perhaps the other one. The other one's the one that's incomplete. But okay, yeah, let's just walk through this one a little bit. So we have the creator facet, we have the creator invitation, and we have a public facet. So creator facet is going to return a make bid invitation for key, which is essentially going to take, as you can see here, an item key, which will represent the NFT that you want to make a bid for. It will also have a get available items, which will return all of the items that are currently for sale. It will have a get items issuer, which will return the issuer of the items. And it will have the make withdraw invitation. That's to essentially withdraw from the auction itself. Then we have the get completed promise for key, which will return it will take in the item key, and it will give you the result. And then we have the get session details for key, which will essentially give you the state of a given auction passing along the key. So yeah, so for this, the whole idea, like what we're going to try to do is, let me show you already in the contract here. So we want to mint an NFT, right? Now an NFT is going to be composed of either a string or an object. In our case, we're just going to use a string. Ideally, you would probably want to use an object in order to add more properties to it, like perhaps you want a URL with an image for it and some metadata, say a description or something like that. But because of complications with the UI when using an object at the moment, we're just going to do it with a string. And we'll go ahead and define the NFT that we want to mint by just passing in the URL of an image that we want to display as that NFT. The way that we will do that is in the deployment script. We will go ahead and specify the NFTs that we want to mint, and then the contract itself will take those, mint them, and create an auction contract that will allow people to buy that NFT in an auction manner. So, okay, one thing before we start, once you download an Agoric project, the first thing you're going to want to do is run Agoric install. So let's go ahead and do that already, because that process can take a little bit of time.
Do we want the beta branch of the SDK?
Sorry?
Do we need the beta branch of the SDK, the Agoric SDK, or the master?
You want the...
I think you need the beta because it's written in the Git repo.
Yeah, okay. Thanks.
Yeah, so you'll want the Gateway to Cosmos Quick Start branch.
No, I meant the Agoric
The Agoric SDK.
Oh, yeah.
Yeah, it takes me 5 minutes already.
Yeah, but regardless. So the flow is a bit like, so you first run Agoric install, then you run your, so Agoric install, what it does is it goes through all of the dependencies for each part of the stack, and it installs all of those. So for example, if you make a change in a dependency in your API or in your deployment script, then you need to run Agoric install again, just for those changes to come into place. You shouldn't be running like yarn install or things like that within either the API or the contracts. That's all handled by Agoric install. The UI is a little bit different. You're free to run yarn install on that one. Now. After running, so we don't have to do it now, but like just the workflow is a bit like run Agoric install, then run the deployment scripts that will compile and deploy the code as well as the API. And then you would normally open the Agoric wallet by calling Agoric open REPL. And then lastly, you would start up your front end. And those should be all the necessary steps to test the application fully.
Of the init, Agoric init command in the README file. There's Agoric init doc.
Oh yeah, this should not. So this we took the baseball card example for this, and we haven't actually updated the README.
Okay.
But we've modified the project quite a bit. So yeah, you don't have to worry about the. But
I didn't.
are you running into any issues?
No.
Oh, okay. But yeah, let's we can ignore the README.
So how should we run it?
Huh?
So it's basically Agoric install. Then you want to Agoric start with the command that actually is in the README, that's
Oh.
fine.
Oh yeah, okay, let me just write the command, yeah, sorry.
So anyway, if I want to add some dependency or let's say in the contract, I don't know if I want some client to use algorithm, or should I just go directly with that?
So you can just add it to your package JSON and use it, and then you do Agoric install. If it's in the contract or API layer, then you do Agoric install. If it's in the front end, then you don't need to do the whole Agoric install again because that's quite separate.
Correct. So Agoric install just installs all the packages for all the different parts of the stack. Then Agoric start is what starts the Ag Solo, which is a blockchain simulated blockchain, and deploys the wallet. There's a couple options you can pass here. You can do reset, which you most likely want to do if you make changes to your contract and things like that. And then there's also a rather useful one, so -v for verbose, who that will essentially log more information in the running Agoric, and then that could be useful for troubleshooting. After that, you would have the deploy, so Agoric. And here you would pass the reference to your deployment scripts. So first you would want to do the contract. Okay, so these are basically your steps. Excuse my handwriting, but yeah, Agoric install for installing all the dependencies and API contract directories. Agoric start the chain and the wallet locally, of course. Agoric deploy to deploy plus the location of your deployment scripts to deploy first the contract. And then the API. It is important that you do it in this order, because if you were to try to deploy the API without having a reference to the contract, then that would fail. Once that's deployed and there's no errors, then you would run Agoric open -e or REPL, which is what starts the wallet UI. Something to note here is, so this just opens in localhost 8000, but you can't just navigate to it because it uses an access token, so you do have to start it up this way. I believe the access token is also logged in the console, so you could also...
Also, I wanted to ask, do I need to have some wallet installed, or it's like...
No, so they are working on making this wallet available in services like MetaMask, but for now, we do have to use the UI wallet, which is packaged within the Agoric project.
Okay, so that means that it's not like available to public yet? Or
Well, it is. So you can still use your wallet and interact with contracts on the testnet, but it's just not integrated through services like MetaMask at the moment.
Yeah, okay.
But it doesn't mean that you can only run it locally. Like, you can still use that wallet, and that wallet can still be interacting with a network.
Yeah, but you have to run it yourself.
But you have to run it yourself, right? Yeah. Okay, so let's just have a look at the contract, and we'll see what kind of things are missing, and we'll try to fill them up together.
It's a good thing to mention what happens after you run the UI, that you have to accept that.
Oh, right, yeah, so a little bit of the whole flow, right? So once you've done all these things, you would have your contract deployed, you would have your API deployed, you would have a constants file with references to those, and you would have your front end running. Now the front end will be, yeah, I can actually show you. So in the front end, so what we've done here is just a React app. First thing to note is in the entry point of the application, we're calling install secure ECMAScript lockdown. So what this does is it actually enables secure ECMAScript to secure this application. And it's important that you do it at the beginning, otherwise you may run into some issues with other packages or other things that are being imported first, and then that could cause a lot of issues. There are a couple of other ways that you can go about this. I believe there's also a package called endo-init that also calls the lockdown function. So you could also just import endo-init and just importing this like such, or sorry. Like this. That should also be valid. There are just different ways to approach it. You may get mixed results, but again, this is something that applies to your whole front end, which normally uses a lot of different packages. And as you may know, the JavaScript client is a bit of a mess with global variables and things like that. So it's sometimes very difficult to know what your packages are doing and what kind of things they're going to try to do. So when using secure ECMAScript, you may run into, will be logged as a type error issue that you will have to fix in order for secure ECMAScript to be able to do its job properly. So okay, that's out of the way. Then we have the application here. And what, so I try to put most of the stuff in just the main file here, app. But what this is doing is essentially we're just keeping track of some state here with React use state, and we have a use effect that's going to run when we first mount this component. And then this is actually calling this need approval, which comes from yeah, so okay. A lot of the stuff that's happening in the front end, it's a little bit too complex to go into now. I mean, we have 20 minutes, but you have things like this, so a WebSocket connection here that handles the, enables the local bridge. You also have the API client here that's utilizing those socket connections in order to connect to the DApp. But yeah, we don't really have time to go into detail on this, but all you need to know is that these files are essentially can be used to establish that connection to the wallet, and there's really no config necessary here. Like, as long as you have these, you can actually make that connection, and I'll show you how these are actually used, because you also have the Agoric wallet here that has the bridge, and so yeah, essentially what you need to know in terms of being practical is that as long as you import these, and you can find these in a lot of the example applications on the Agoric repo. But the way that you use it is determined here in the app. So we're going to need that approval, and this is what's going to go and use the bridge, the connection that was done to the wallet from the front end, and it's going to tell the front end, hey, it's going to tell your wallet, hey, this application, this front end is trying to interact with you. Do you want to accept this? And once you do, then that front end is able to suggest things to the wallet. And in doing so, what we actually do here is we await these suggest installation, which is essentially telling your wallet, hey, I have this installation board ID that refers to the application we deployed. I suggest you install it. And then in your dApp, in your wallet, it will actually create the necessary purse based on this issuer. So it'll create a purse for the NFTs, and it will have the instance of the application. So once you have that, you await these, and then you can get access to Zoe, the board, the instance, and the public facet for the contract that we deployed. So having access to that contract, then what we need to do, for example, is, well, now we get into the methods of the contract, right? But the contract that we're going to write is going to return an instance of the auction contract, and the auction contract has a method to make a bid for an offer. So to call that, we are actually doing that in this auction file. So it's called buy NFT, and it will take a reference to the wallet. It will take the NFT that you want to buy. It will take the public facet. It will take an NFT purse of the user that's going to be receiving it. A token purse is going to be used for payment, and it will take the price. You don't have to worry about a lot of this. This is all like set in the sell or in the auction contract. But what I want to emphasize here is that now from the front end, we have access to this public facet, and we can actually go and call a public method on that contract. So now, for the first time, we have kind of explained how it goes, is essentially from writing the contract to calling it from the front end after having established that connection. Running out of time, so let's get to fix this, and we can run it. But any questions on this? Okay.
I think there's one important thing to note that we also found out that you can get purses by currencies. So you can, like earlier mentioned, you can have multiple purses of run, for instance. And run is used to, for instance, this here to buy. But that also means that once you retrieve those purses, you get actually an array of objects. So you need to ensure that you actually use the correct purse to pay for it. So else you might run in, oh, I don't have any funds, or you accidentally pay from the wrong purse. That's something to take note of, and eventually also give feedback to the user, hey, this is the purse that you're using, or give more of a select there, which we're not going to do now, but that's definitely good to keep in mind when developing larger apps.
Yeah, so essentially, once you've established that connection and once the wallet has approved your application, the application will have access to the different purses that you have on your wallet. So it'll be able to get a reference of those in order to interact with contracts. So okay, let's fix up. So the contract that we need to fix here is it's just called contract, And so if we could all go to it, we could go ahead and get started. Now I've just removed some of the things that we need, but I want you to pay attention to this mint NFT function. So this is essentially what's going to create that NFT and put it up for sale. Now what this takes is the NFT itself. It takes a money issuer that we're going to use for payment in the auction. We're going to take an auction installation, which is essentially a reference to the auction contract. An auction items installation. The minimum bid per card, or NFT in this case. And then a time authority. And time authority is just used, it's a helper that enables the auction to have a specific duration. So that's all within the auction contract. Now, what we need to do in this method is essentially mint the NFT. But you may have noticed that we don't really have a mint at the moment, right? We haven't created the token. So if we remember, there was a couple of ways that we could do this. We could use the make issuer kit, or we could use the make ZZF make
ZZF
mint, yeah. So first, we just need to get our token defined. So we need to get an issuer, we need to get a brand, we need to get a mint. For that, we're just going to use the make issuer kit. So we're just going to define our issuer, our mint, and our brand. And that's going to be returned from make issuer kit. Do you guys also have IntelliSense, or is that, I kind of forgot if that's by default, but I think it should be by default. Okay, cool. If it doesn't pop up for you, then you just need to import, or well, it's actually already imported, never mind. All right, so make issuer kit, like we said, is going to take a couple of things. First of all, it's going to take the alleged name, which is how we want to call the NFT. Feel free to get creative. I'm just going to go with Kryha here. Kryha NFT. Secondly, we need to tell the issuer kit whether we want a fungible or a non-fungible token. In our case, we want a non-fungible token, so we need an asset kind of set. This is going to indicate that we're going to make NFTs. All clear so far? Yep. Okay, cool. So then we need to, when we call the mint NFTs, we want to pass along the NFT that we want to mint, and then we want to create an amount out of it. So because it's an NFT, we can pass one of two things, either a string or an object here. We're going to work with strings at the moment. So to make an amount, there's a helper function called amount math make. And then what that takes is, first of all, the brand of your token and then the amount. Because it's an NFT, like we talked before, our brand, we're just going to take the reference to the brand that's returned by the make issuer kit. And secondly, we'll pass the value, which in the case of NFTs, if you remember, is not a number, but the object itself. Now, one thing to note here is that you can actually mint multiple NFTs at once simply by putting this into an array. So let's just go ahead and do that. And we'll just take whatever NFTs are passed in here to this function and put them right there.
Shouldn't we harden them?
Not yet. I mean, we could, but it's not necessary at that point, because if you or well, you could harden it here. Yes, indeed. So it doesn't matter whether you harden it here or when you actually pass it to the mint method. But yeah, it's exactly the same. So sure, we could do it here. So if we harden.
And what does that mean?
It's
So
basically freezing the object.
yeah, so it's making it immutable.
Yeah, okay.
I just hardened NFT's thing.
Hmm?
I just hardened NFT's thing. The value. Let's try it.
Oh, this one. Yeah, sorry. Oh.
So it's best to just harden the actual value that you put in. So in this case, it would be NFTs. So just the actual value that you pass towards the amount make. That's what you want to harden because that's what you want to make immutable. Because you always want to make sure, so okay, just pass these NFTs, and this has to be always these.
Is this? Just make this a little bit bigger. Okay, so once we have that, we know how much we want to mint. Now, this doesn't hold the value at all, like we need to actually mint it. And to do so, we can just use the mint method returned by the make issuer kit. So we will go ahead and do mint payment. And as you can see, this just takes a new amount. So we'll just pass the new amount for cell that we just created. And then we can make a proposal that we can pass along to the auction instance. But first of all, let's go ahead and create the auction items terms. This is something that's taken by the auction contract that specifies things like the bid duration, what kind of mechanism you want for the winner. It gets the terms here, and then it takes in the auction installation, as well as a minimum bid and the time authority, which is the helper for enforcing that bid duration. So with all of that, we now have the terms. We have imported the installation. We received it from here. So we can go ahead and start an instance. And then that starts an instance, passing it those three things, including the issuer keyword record, which is taken from here, and this is what you're going to use. This defines the currency that you will use to bid on the NFTs. And then here's one way that you can do checks in your contract by using the assert function. Here is just checking that the creator invitation returned by that start instance is the auction items contract, or that is valid essentially. And then if that is not valid, then it will return this message here. So then we make an offer to the Zoe service, and we return the newly created instance of the auction that was created. So at this point, we passed along the NFTs we wanted to mint. We minted them. We created a instance of the auction contract that contains those newly created NFTs. And then we're just going to return the creator facet of that auction contract, as well as the instance and the public facet. So now that that's all done, we can just, there's one more thing to fill in here, which is the creator facet get issuer, which will be used to retrieve the issuer of the NFTs so that those can be interacted with by a wallet. So simple enough. we just go and return the issuer. So, with that done, it should be complete. So if we just save this, and I actually should have started my...
So you could explain where we define NFTs and how that's done.
Oh, of course, the API. So I'm not going to go through the contract deployment because...
Can you go again what you changed in the file?
Oh yeah, of course. So changes needed. We have first of all, we create the issuer mint and brand by using make issuer kit. I will also push the finished version as well in case you want to get the code after or anything like that. But that's one. Then you have the other change was making the amount with this amount math. And then you have the mint payment here, which actually creates the NFT and mints it. And then the last thing that we needed to do was to pass along the issuer on the creator facet so that could be retrieved by the application. So from here, then you've probably already done install and start. Is that correct?
Not really. There are some errors.
Oh, some errors.
Yeah, it was like the module something.
Could you run agoric-v version? Sorry.
Yeah, it worked. I think 1 point.
Is that the contract module? Which
Mm,
probably just
no specific one, but agoric version is just a troubleshooting step that can let you know whether your agoric SDK is actually installed globally on your computer. So sometimes when
Which version are you using?
which what?
Which version of Agoric are you using?
So I actually was working on my laptop, and now we're doing it on another laptop. But
It's the agoric fee, right?
yeah, let's just check it out. So to see the version, you can just run agoric-version or agoric-v. And we seem to be running 1321.
And you mentioned that there is a lot of things are abstracted, but is there a way how can I somehow see what is my current wallet I'm deploying with? Is there a way?
So that's if you go to Agoric Open, that's when you basically have the whole wallet that you're currently using. So the Agoric Open -REPL, that should open a browser window, which basically shows your whole wallet and the purchase you're currently holding. So that's also, once you open the UI, that's where the pop-up will come, which basically asks you, hey, do you trust this app or do you want to use this app? And I say yes, and then basically connection is established.
So something like public address, is that something? No.
No.
Okay.
It's not really a public address. You simply just interact by having the board ID. So if you know the board ID, you have a reference to that, and you can pass along to anybody, and anybody can go to Zoe saying, hey, I know about this board ID. And then your wallet itself could also be, you could pass a reference to it so other people can make invitations, essentially through the...
I'm not sure if they have plans to actually expose some more Cosmos stuff as well within the wallet itself, but at the moment it's mostly just focused on how they actually interact with Agoric and not necessarily the underlying Cosmos layer. But I think there's some plans to make more of an integration, right? Yeah.
Okay, I don't want to keep you guys a lot longer because I know we're already running out of time, but let me just really quickly tell you about how this is deployed. And so the contract deployment happens just like the other one. It's only just putting it in Zoe, getting a reference to it. But in the API itself, we are actually so we start an instance of the NFT contract. We get the facet, and then we are actually where is this? We are actually calling mint NFT on here, on the deploy script, which is essentially already going to take an NFT or an array of NFTs and mint them and create an auction for it. Then what we're going to do is we're going to save a reference to that auction contract, and we'll just export that to the front end so that the UI can actually interact with that auction contract. Now, there is a file here called NFTs. It currently just contains these two URLs. But feel free to change it, if you want a particular image in your NFT, then just go ahead and throw it in there. But it does need to be a URL that can be resolved from an image component in HTML.
Do we have some metadata for those NFTs?
So we don't, and that's a bit of a design choice. So you can actually pass an object rather than a string into the.
It will be on-chain.
Yeah, exactly. So the whole thing, the whole object would be encapsulated in the NFT, and so you would pass it around, and anyone who has a reference to it will be able to get those.
And again, do we have some limits on
well, now you do run into fees, depending on that, right? Because now you're actually putting that in the contract. So, I mean, you can add as much metadata as you want, but just make sure you have enough.
Eventually, also your gas limit will probably exceed. So I'm sure that
right.
in the background do a transaction that will eventually fail, which you'll probably see within your node that says, hey, if you're running verbose, this is going wrong. You most likely won't see it in your UI because of the SES stuff. So a lot of the debugging you have to do into your Agoric console running verbose. That opens a lot of information for debugging. So it's definitely useful. But yeah, you can indeed create an object, and that object can then have a reference to IPFS as well, where you, for instance, host an image.
Okay. And do we have upgradable NFTs here? So maybe some logic to upgrade this metadata?
No, the metadata or anything that you pass along to the NFT itself, so anything that goes into that mint method as the value, that will be immutable. So you won't be able to upgrade that if that's what you're getting at.
Okay.
Yeah. Of course, there are other patterns you can use, right? Like the metadata of the NFT can just be a reference that then the front end or other parts of the application can attach other metadata to, right? So, so yeah, there's a lot of different design patterns that you could use here. Now, cool. Let me see. This is not finished yet, right?
You can, no, I don't know. I think it is. Scroll up a bit. If you see purple stuff, then it's done.
Yeah, so when
Purple stuff, so it's done.
It is done.
So it basically, it needs to be fully set up, and it does this command where it says, hey, something is done. I don't know.
Yeah,
exactly.
the script, but
yeah, the script is done, and then you can actually run Agoric open to open the wallet, and your chain is basically ready to run. Then you can run the deploy script that should then succeed, and should actually change the configs into the appropriate folders that are defined within the deploy script. Then you can start the UI and get the connection.
Exactly. So we're done with the Agoric start. We got the network going, wallet deployed. We'll go ahead and run the deploy scripts. And then I don't know if you guys have already gone ahead with this or not, but if not, then please do run Agoric deploy, and then the reference to the two files, first the contract and then the API. And as you can see here, it's logging the board IDs that we've retrieved in the deploy script. So first, it just did the contract. So the contract successfully installed on Zoe, and we have the reference to the installation as well as for both the NFT and the board. And then the API script runs, and then we get the contract name We get the board that references the specific instance. We get the brand of the of the NFT and the contract itself, or a reference to it, anyways. So now we go ahead and open the wallet by calling Agoric open -- REPL.
So was there something you did in the deploy API deploy script? Because I got the error with harden. That's something that I'm passing from frozen object.
Yeah, did you run Agoric install?
Yes,
yeah. You did.
I did. Same problem.
Let's check it out.
So the first deploy of the contract is
It goes through. Good.
And the second one, I got is cannot pass on frozen object, like use harden.
Like an object. Okay. Let's check the.
So this is the deploy. What I did, I tried just this change to add harden here, but it doesn't make any difference. The error is still there. So
No, I don't think we need to harden there necessarily. Yeah, and then, but it could be that this is erroring now because of the contract. Right. So we need to actually harden it here. So we need to harden the NFTs that are passed into. So in the contract.
Yeah.
Yeah. And now.
So even though.
Let's see. No, this should be correct.
Yeah.
Yeah.
A lot of those examples that are just within the repository, also one in ours, those basically have a lot of those connections. So it's setting up those WebSockets and basically connecting it for you.
Okay, yeah. So there is a type. There's a type system that you have within this, and here apparently it's defining that it's going to return a public facet. If we simply remove this, then that. Oh, sorry, I'm used to the Mac. That should maybe clear that out. Yeah.
Okay.
So that should do it. It's just a typing issue. It should look like this, correct? Yeah.
You don't see the image, right? I look into the issue. I have it here.
You have the.
Yeah, you try to the request URL. There are both URLs are connected with.
Oh, okay. Oh no, I pushed broken code then.
.jsx, maybe around this line. I don't know how this works.
It's most likely.
You think somewhere else?
Oh, yeah.
So nobody's getting the image?
I got it.
You got the image?
I think. No.
Oh no, yeah, but it worked. No, I think I'm sorry, I pushed broken code, but that should be in here. And we should only pass one of those. Oh, wait, where's the app?
Maybe I have to find it again.
NFTs, map, NFT.
Oh, you just uncomment card detail model.
Oh. No, that should be working.
Unideal, let's say that.
Yeah, come on, Carlos, your code is broken.
I think it's also definitely very valuable comments if you.
Or let's see, the other thing that I'm thinking of. Could it be here?
They're also very much
Oh, these are just an array, so it's okay. Let me run it here for everybody, and then maybe we can see if we can figure that out. Okay, so hopefully you got the contract deployed, and then you were able to open the wallet. And yeah, I think a lot of you already did this, but we just need to run yarn start on the UI folder, which should open the UI. And then the way that this works is actually, if you look at the if you look at the console here, you can see all of the calls that are being made between the UI and the wallet. So it's looking for wallets in the network, and it does find one. And so if we go to our wallet, we can see that we have a connection offer here. And if we accept, then you may notice that a new purse should be created within your wallet. It should be based on the issuer that we exported from our contract, which is this NFT purse here. Once that's done, then this should go on and fetch the available NFTs from the contract. And then, yeah, for some reason...
I think you have an RNS bracket within the contract, actually.
A what?
You have an RNS bracket within the contract. The harden, you pass an array, and you already pass an array from the NFTs. The export const is already an array.
The export const is already an array?
Yeah, so here this,
this is old code.
if you go here, just contract. This one that should be an array. So it's already an array.
Oh, okay. Mistake, honest mistake. We so here when we wrote the contract, we're already passing an array, and then we're creating a new array with that array inside, which we should not have done.
Yeah, that's, I was thinking that there will be an error.
Yeah, so that's essentially changing the format of the NFT, which is now being passed to the front end in a weird way. So our front end was not prepared to handle that an array rather than a. But so it's an easy fix. Just remove these guys.
You do need to agoric deploy again.
Exactly. So now we don't necessarily need to stop the chain and reset it, but we do need to deploy it once again.
Can you update the existing instances?
The existing what?
Instance from a contract.
No. So when you deploy it again, you're deploying a new one, and in fact, you will see that the new board IDs will be different because it'll be pointing to a new instance.
Do we need to pay some fees when we deploy a contract?
Yes, you do.
Basically, it's like transaction, and if we right now on our local system,
So you do need to pay fees, and you can see that here in the deploy script for the what's it on this one?
So do we have like wallet with some stuff on it already?
Yeah. So when you start the Act Solo, it will have like you can see here. I think it has 53. So yeah, so you can see here it's a 53 run.
That's fine, but you have the wallet open, right? So go to here. You have that's all your personal. So you already all the funds you have. So once you connect, you will also see an additional purse pop up here, which will hold your NFTs later. So once you actually buy them, they will transfer to that purse, and you should see, hey, I have one NFT now, or if you buy the rest, you have multiple NFTs.
Yeah.
So we deploy it then.
No, you don't. Because it's already open, it's fine. If you redeploy it, should just put a new instance of the purse on you.
So, yeah, one thing to note is we've already given access to that contract, but it does have a new. It does create a new instance and does a new purse of NFT because they have the same name. It's just named as NFT2. But now, as you can see, the images should be fetched correctly.
You can buy one and it should end up in yours.
And then if you hit buy, it will actually call that method that we talked about earlier in the front end, which was the buy NFT, which calls the auction contract, and it calls make bid for key. So
this is through your wallet, so you have to actually accept, do you want to do this through your wallet? So then
right.
you go to the wallet interface.
So now after clicking buy, you would have to come here and you should receive an offer. And this is something I didn't get to talk a lot about today, but a huge thing with Agoric is this whole offer system where you have offer safety guaranteed. So essentially it's either you get what you wanted and give what you're willing to give, or you just get back what you wanted to give. So there, even if it crashes or no matter what happens, you're guaranteed not to lose the assets you escrow unless you receive what you wanted for them. But yeah, so here we got an offer, and one nice thing about this is like it by design sort of protects the user from making mistakes, right? Because now it's very clear what's going to happen here. Like I'm going to give one run, which by the way we just hard-coded in the front end at the moment, but you could pass different methods to the contract. And then what I want is an NFT asset. And because we redeployed and it was now NFT2, we know where that's going and what kind of asset it is. It's the one that corresponds to NFT2. If I accept this,
It takes a bit.
it'll take a moment, but eventually should resolve, and then moments later, the balance should go up on your NFT
Great success.
purse. Oh.
Yeah, I think we do have some more information to show. So we have the, if you go back to the slides, and if you go to the next one, so Agoric's also doing a hackathon, and we've here posted some ideas you could do with NFTs to extend how NFTs are used, which you can create some contracts or extend current contracts. So there's some auctioning models. You should probably talk about this because you have the mic, but.
Oh, yeah. So okay. So here's some hackathon ideas that you could that you can run through. Now with Agoric, it makes it super easy to program logic in terms of different mechanisms for transferring assets, and it's super flexible. So you could first of all you could. In a similar way to how we now created an instance of the auction contract, you could leverage the contracts that are already out there in the provided by Agoric, and they have a bunch of them. So they have a few in terms of like selling, so simple like sell token. They have a barter exchange. They have a an auction contract. So you could very easily just take those components that are already there, and they just take a specific issuer that you may want to use, and you can just use them within your contracts. And it should make it a lot easier for you to just not worry about certain logic. But yeah, so marketplace functionalities, we have different kinds of auction mechanisms, dodging the sealed bid, bonding curve. You can also maybe use some of those time authority things. By the way, offers can also have terms. So for example, you could make an offer expire within a certain amount of time. You can set mechanisms for allowing them to back out of their offer or maybe disallowing it.
You don't have to get this deep. But
yeah, okay.
We generally wanted to give you some ideas. You could start during the hackathon, think about it. Don't tell them what they want to do. They mostly have amazing ideas, I'm sure, but
yeah.
just give you some ideas additionally.
Oh yeah, if you want the money.
So really quick on this. If you go to gateway.agoric.com, it basically walks you through the process of how you submit the screenshot. And for the screenshot, basically, if you set the brand to your first name and your last name, and you have that show up, the NFT show up in your wallet, send me the screenshot through that link, or gateway.agoric.com, and then we'll send you $200. That's the reward of completing the workshop task.
So just this?
That with your with the brand being first name, last name. So I know it's
Yeah, okay.
the person's video.
Okay, so I don't know fake brand I said.
So они already put smart contract again, yeah?
Yeah.
Yeah, let's check it out.
Just change the brand name.
Is it my wallet?
Yeah.
I didn't set this brand.
Yeah.
Or did I?
We did actually. So if you go to the contract, I can show you where we did that. So brand is being, if you look for
The issuer kit,
You
right?
can always, yes, that's true. You can always inspect it.
where is that input? Oh yeah. So the issuer. Oh, you're saying that the brand itself. Yeah. So there's more to it than just the brand in terms of. So if you were to log get token brand in the contract itself, it will return this. If you have an asset of this kind, or if you have this issuer kit, and you call, I think there's a method get issuer record that should return this. But we have currently in the UI, should be in here, we are suggesting them to install that issuer, and we're actually giving it this name NFT, and that's the reason that's showing up like that. So you could, so if you change this one to the name you want, then it would be called like that in the wallet. Yeah. Also, you can in the wallet you can also have different names for your.
Oh yeah, sorry. I'm trying to
For
Okay. And one thing, how do I send this? Like, this is quite confusing. Can I send it or not?
Honestly, I'm not really sure how you would send it directly here.
Yeah. Okay.
But you could have an application in the front end that now uses this wallet. In fact, I think if you go now to the front end, a lot of these things contain reference to the wallets that you have. For example, this one, and it has that brand pet name, which is like a human readable name. That's also why it's not the one that you put in the token itself. But you can see that it does have the balance here, and you could interact with the contract through here.